I first got into robotics around high school, freshman year. It was the first time that I had actually joined a after-school extracurricular club, and my friend Connor, who lived across the street from me, he just invited me out to the club, and I had no expectations of what was going to happen. They were part of this organization called TSA, or Technology Student Association, and the organization has all these different competitions, and this advisor was just handing out all these different assignments to different people at random, and I was given animatronics. We were given no instructions, so we had to learn how to quickly build a robot that this is animatronics, so it has to look like an animal or an inanimate object that was brought to life. The first thing that I've ever built where I thought this is exciting or I want to keep doing this, I think that was building electromagnets. So in first grade, I was in Mrs. Winter's class, and we were studying different science topics, and I realized that I really loved a science class, and the science class that we were taking was magnets. And I was just fascinated because there's these, little metal pieces that you could take to other things that are made of metal, touch them, and they would either attract, or if you brought it close to another magnet, it would either attract or repel. And then at this point, I didn't know how magnets were made or how magnetic fields could be induced, but my dad had me wrap a wire around a nail, just basic household implements, and when we ran a current through it, this nail could now attract other things just like a magnet, and when we disconnected the power, it would stop. So I thought that was very interesting. Most of it started in high school. I had always been interested in science. My parents gave me a lot of science books. I had one book called The Big Book of Experiments, and it would list different experiments like electrolysis, generating hydrogen and oxygen, or how to build a camera using a shoebox and a magnifying glass. And whenever I needed parts and I would talk to my parents, they would kind of dismiss me a little bit. So I didn't actually have any access to parts that I needed to build anything, but I always knew that I wanted to build things. When I got to high school and I joined the engineering club there, I was given access to a budget so I could order parts on Amazon, so like Arduinos, and this was new at the time, a 3D printer. And no one at the school knew how to use the 3D printer, but I remember that in middle school I took a Google SketchUp class, and I thought, okay, if I can generate 3D models in Google SketchUp, can I actually make something? And for the animatronics competition, we realized that I could use Google SketchUp to make parts for robots. This all still goes back to the animatronics competition. We were not told how to build a robot. We looked at other videos under TSA animatronics, and for the most part, people were sticking Lego Mindstorms part or Vex parts in teddy bears and making them move and say things, but it was all kind of creepy. So my friend who invited me to the club, apparently he'd been tinkering with Arduino microcontroller boards for years up until that point, and he said, why don't you use that? And no one around us knew how to use Arduino, none of the teachers did, so we had to read books, watch YouTube tutorials, and just do all the research ourselves to figure out how to use an Arduino microcontroller. The formal education when it comes to microcontrollers doesn't actually start till university, but when we took a look at it, the difficulty was in having to find the resources to help ourselves, but it's not actually so difficult that high schoolers or even elementary schoolers couldn't master them. I'm not exactly sure when the startups came into this. I think it was after another friend of mine showed me this HBO TV show, Silicon Valley, that I was fascinated. At that point, I could do a little bit of HTML programming and had some electronic skills, and I thought, what if I studied enough to build an app and use the app to build a business? I spent a couple months actually studying to learn how to build apps. One of the first YouTube tutorials I saw was for something called MAF, Mobile Application Framework by Oracle. I picked it because it used a programming language that I knew called Java, and I used that to build an app called Jargonaut, which is a multilingual glossary for technical terms in many languages. One problem that multilingual people actually face is while they can talk about everyday things in all the languages that they can speak, they tend to only learn the technical terms related to the field in one language. Because, you might go to an American high school, but you also speak French, for example. In this case, it's not a dictionary that you need to look up words one by one. You need to have all the words clustered around the subject that you like. So I decided to create an app where you could choose your primary language, the secondary language that you want to know the terms in, and then you pick the subject that you're good at, and then you just go through all the terms so you can learn them all at once. Spoiler alert, that particular startup didn't turn out well, but I'm the kind of person that I try these things over and over and over again until I actually succeed. little bit of a chicken and the egg question, but the robot came first. So our submission for my high school animatronics competition was a 4-legged robot. All the parts were modeled in Google SketchUp. Everything was janky. It was so heavy. As it walked, it would just slump. We couldn't provide enough power using these 9-volt batteries that we were using. And while we could make it do some movements autonomously and it was enough to win state, it wasn't a complete product. I always wanted to try again. So this first competition was first year of high school, and I've built a few robots since then. And I always wanted to do a 4-legged quadruped again. So a couple years after I graduated University of Washington with my computer engineering degree, I decided to try again. I made a thinner frame. I actually designed it. I was wondering, what if I could design a robot that was essentially a microcontroller board with legs? A microcontroller is very, very good for prototyping. Essentially, it would be a robot that would be very, very easy to build, but you could extend its functionality. But also, microcontrollers are very, very good when it comes to education, because in order to use one, you need to know about electronics. You need to know how to program. I imagined a tool that'd be very, very good for me as an engineer, so I could prototype new kinds of robots with new kinds of sensors and hardware, but it would also be something that would be easy for students to learn about basic concepts relating to electronics, programming, and microcontrollers. At the point that I created the design for H.I.R.O, I had already done a few startups before, so with that experience and a lot of mistakes, I now know how to recognize the value of a startup. And in this case, it's if you have something on paper that you know that someone will buy, in this case meaning, can you find a first customer? And I actually did find a first customer. I called up my friend David on the phone because he works in education, and I was wondering, do you know anyone else in education who would want this? And he says, Joe, I want 40 of them. And at that point, I knew I had enough to build a new startup because I had an idea and I had a customer, and I also had the ability to make the product. For me, it was the first taste of competence. I'm not quite sure how to describe it. I found that I was actually very, very good at building robots. Everyone tended to specialize in one aspect of robot making, so either the electronics, the programming, or the 3D modeling. And because I was the only person who could 3D model at the time, my job was 3D modeling and designing the plastic pieces to house all the electronics. But I also found myself helping everyone else with the programming, helping everyone else with the wiring, because I kind of had a knack for everything. And then it was the first time that when it came to building things that I thought, I'm good at this. Initially, I wanted a toy for myself. I wanted a robot that looked alive, that I could quickly prototype electronics on, that I could mount a Jetson or a Raspberry Pi so I could start experimenting with AI and ROS integration. But I also wanted to connect microcontroller education to robotics education and to fuse them into one. So microcontrollers, it's already easy to kind of teach people. As I mentioned before, it would be easy for elementary schoolers to learn. Just as long as all the pins are labeled, the headers are easy to access with jumpers. And I thought, let's make the 3D modeling part easy as well. If you look at H.I.R.O, a lot of the parts are flat. You're not using complex tools. If we ever taught a 3D modeling class around H.I.R.O, the progression from starting with a blank sketch all the way to a full robot would not be that difficult. So by current robot, you mean this one is first generation edition. So this is Gen 0 edition. So this is the prototype that we worked with. You mounted a Raspberry Pico on this breadboard, and it connected to all these servos, and it worked. The problem is it requires a little bit of intermediate level skill to put together. It takes a little bit of time. So this is the first generation edition. This is a PCB you can buy from us. It's very, very customizable. So here are breakout headers where you can connect to the Pico. It's very, very easy to connect the servos to the PCB, subsequently to the Pico. We mounted a gyro accelerometer on there. And you can also attach an optional ultrasonic distancing sensor. Out of the box, it's actually very, very powerful, very, very customizable. And we actually mounted a battery on here, so you can actually, with Bluetooth, control it from a distance. The answer to that is kind of yes and no. So I did make H.I.R.O as a creative platform. So anyone making the most amazing things with H.I.R.O is something that I do expect, but how that turns out always surprises me. So today I saw our test engineer Leo building a game similar to the game Simon with H.I.R.O, which is an application that I did not think of. We actually piloted a robotics course with elementary schoolers in the Tacoma Public School District. And to us, this was actually a little bit unideal because we wanted to try with middle schoolers first because we thought middle schoolers were a safer demographic. They were bound to retain more information, understand more information when it comes to electronics and programming. But the two classes that were given were both elementaries. And at the end, I had a couple of my students present the robot to a crowd of parents. And I actually didn't quite have the highest hopes because, to say it in a short way, they snarky. I had a format with the way I wanted them to present, asking them, what do they build? How does it work? And during class, one of my students, his answers was, what did I build? Instead of saying a robot or a four-legged robot or some answer that was actually true, instead of thinking about it, he said a masterpiece. But on the day of the presentation, he was amazing. The parents had never really seen the robot move. They thought it looked like some janky toy. And then he plugged it in and it just came to life and just started marching towards them and they all jumped. And during the middle of the presentation, some wires came loose and he fixed it in front of the crowd, and they were already amazed by the technical ability in his presentation, but they were further amazed by his quick diagnosis and repair of the robot live on stage. One thing I pride myself on is I'm very, very good at finding people who are talented in different aspects, finding good programmers, good marketers, and then arranging the company in a way that they'd be very, very enthusiastic about it. So giving them the chance to complete projects that they've always wanted to complete, build things that they've always wanted to build. And when it comes to robotics, there's so many things you can do. So our web designer, for example, he is an electrical engineer, but he's not as fond of it as he would like to be, and he wants to be a programmer, and actually he's very, very talented at it. During the course of this startup, we've actually didn't have that much money to work with. So instead of saying, let's pay monthly fees for AWS cloud hosting, we actually built our own servers, and he was just really, really up for that. And so we built our website from scratch on servers that we built and set up from scratch. He built an entire development, testing, production pipeline, and it's absolutely amazing. Everyone knows how to direct themselves. We have a graphic artist and she wants experience designing the UX for websites or designing character art for robots or brochures and packaging. When we give an assignment, we don't actually have to give her much direction. When I give our web designers an assignment, he doesn't need much direction because in the same way that H.I.R.O was a dream project for me, the other aspects of building this company is a dream project for everyone else. I think that's the best way I can describe it. Well, I'm not quite sure where the edge of engineering and creativity are, but I don't know. We don't actually have a rule for your robot or your project has to be, this creative. Everyone on this team is naturally creative in their own way, whether it's when it comes to graphics, web design, test engineering, video editing. Everyone wants to apply their own creativity and we exchange feedback and criticism. We're essentially giving everyone a blank check to do what they want. So I think there's a lot to unpack there. We come from a culture where we believe that anything that is fun isn't work or useful, but this is a product for hackers, makers, engineers. We're the kind of people who believe that a 747 is a toy, that a space shuttle is a toy, that a steam engine is a toy. We're trying to build a culture where figuring out the limits of some piece of technology or what you can do with it is essentially play. So I built a product that is accessible for students but can help make breakthroughs at the cutting edge of embedded systems or even AI. Because at the end of the day, whether you are a student learning how to build your first robot, or you're a seasoned engineer building a test rig or prototype, I hope you're having fun. My first exposure to open source was the Arduino platform, and the idea that you could just go online, find some code that someone else in the community developed and their documentation, and quickly use it to build something, that felt absolutely fun. There was a whole community out there that you never met anyone necessarily, but you felt like they were right there with you. So wanted to build a platform where people were just sharing ideas, what they've done, just allow them to really, really get into how H.I.R.O works. So, we built a platform where our code is public, our 3D models are public, and all these parts on here, these are parts you can 3D print at home. The Pico and the motors and everything else, they are parts that you can get on Amazon. You don't have to go through us to repair your robot. You can do it yourself. Honestly, we're not that big yet because we're just getting started, but word is getting out. We won a pitch competition at University of Washington. We successfully funded our very first Kickstarter, and as of this video, it looks like we are going to fulfill all the orders in less than a year, and both those achievements are pretty rare. Although we are small now, I think we're going to become the new standard in robotics platforms, robotics prototyping, and robotics education. We've had a couple classes so far, including both students and parents. And the students we have, they seem to be having fun because they're the kind of students who seem to be a little bit bored in school because the normal curriculum is a little bit not fast-paced enough for them. We did expect those kind of students to enjoy our curriculum. What I didn't expect though was parents with both advanced degrees or engineering degrees also enjoying the curriculum. They would be giddy. We were doing demonstrations on series and parallel circuits, and a parent who's an electrical engineer and a parent who was who had a PhD in chemistry and a degree in computer science, like he was right there with his children playing with the circuits. So in terms of feedback, parents and students really do enjoy the course, but I was kind of blown away by how much. What excites me the most is the opportunity to see the ecosystem grow. What are students going to do with the platform? What are researchers going to do with the platform? What are the extensions that people are going to build? What are the games that are going to be built on top of it? What discoveries or new kinds of robots will be made because of this platform? What I hope people feel when they hear "We are Takamori Robot," I want them to ask what's coming up next, or what's new, or what extensions do we have for this? What have people done with the robots? What new robots coming down the pipeline? Like, I want people to associate us with, fun and novelty.